Hey, good morning, everybody, and welcome to the SomEThing podcast. The snow has fallen here in the Sangre de Cristo Mountains off grid of northern New Mexico. And I'm not sure what the weather is like there in Bordeaux, Les Chiffres. How's it looking in France today?
It's fresh. It's super fresh. We are entering the winter, and yeah, it's a bit depressing for me, but well,
All right, we'll take that kind of a winter, not the other kind of winter in crypto, but fresh French winter. I can handle that. Hey, thanks for joining and co-hosting today. Les Chiffres, of course, are product marketing maven, and you've also been working an awful lot in recent days on getting the word out about Fusaka and how it's already deployed on Linea. So Linea is on Fusaka. We're going to be talking about that a lot coming up. Les Chiffres has lined up some pretty great guests, both from the Linea team and from the Ethereum Foundation. And so we'll be getting to that in just a second. But before we do, Joe, if you can pop up the Linea Hub, just want to do kind of a quick update to see what's going on around the ecosystem, and let's see what kind of events we've got here going on. One thing we wanted to highlight is that Linea Exponent is still going on. So like if your team hasn't registered, be sure to do so, and we're beginning to see that kind of reflected in some of the other things that are happening around the ecosystem, like Rusty's Proof of Humanity giveaway that's tied directly to the Exponent program. And there's all kinds of other cool stuff going on. The T3 Play NFT and Ticket Mint. And we've got more stuff going on with Artifact. So as always, head on over to the Linea Hub whenever you got a second. This is the place to see what's going on. You can see who the leaders are in the Exponent program, get yourself registered, swap tokens, prediction markets. It's all right here, linea.build/hub. So check that out when you've got a sec. That's mainly what's going on in the ecosystem. We want to save as much time as possible for our guests today. So maybe we can go ahead and bring them out to start talking about Fusaka. We're very happy to welcome today. We've got live and direct from the Ethereum Foundation somewhere on planet Earth. We've got Kev, and also from our Linea team, we've got our product lead, Arthur, and Olivier, our head of arithmetization. We have convened the Council of Geniuses here, and we're very excited to talk Fusaka. So maybe I'll hand it over to Les Chiffres to introduce you guys a little bit more and start the conversation.
yeah, thank you, Eric. Thank you very much. We are incredibly honored to have Kev, Olivier, and Arthur on our stream today because yesterday we achieved something very good. We upgrade Fusaka in real time with Linea, which is the first time, and we want to discuss more about it. What's the implication? How we did that? What will be the benefit for the users, for the builders, for the institution, for everyone, even for the Ethereum communities? And so yeah, I am honored to be the host of those people. So just to start the conversation and the live stream, I have one question for you. What is Osaka? What is Fusaka? And what does this upgrade include, and what are the benefits for the users? I can give the mic to Arthur or Olivier, and then to Kev.
Okay, well, I can start. Arthur, I was going to say, I was going to define Arthur. I mean, Osaka is the latest hard fork of Ethereum that follows after Prague, which followed Cancun, etc. So it's a collection of EIPs, and it brings with it some noticeable changes or some upgrades to the user experience, since you mentioned the user experience. One of the notable ones is the inclusion of a new precompile that allows users to use functionalities they already are well accustomed to on Web 2, such as Face ID and biometric signature generation, etc. In terms of the other features it brings, I mean, it brings predictability to both clients, to clients actually, by restricting the size of legal transactions, but also by sort of bringing a bit of regularity to certain precompiled, such as ModX, which had the potential to basically yield to very unyieldy computations that could be DOS vectors. So those are the main points I would say. It brings predictability to the network and to the clients, but it also has some really nice features for users.
Thank you, Olivier. Arthur, if you want to add a word, or Kev, maybe.
I think that was a very good summary. So all in all, like as Olivier mentioned, we have like some nice UX feature like Face ID and like the fact that it's native, like today with a precompile, so cheaper. We also have like blob base fee that is now bounded by execution cost that will enable like the market to find a better price for blob and make sure that L2s are contributing their fair share. But not only that, but increasing the amount of blob so that we can scale all the L2s.
Yeah, and I think scaling all the L2s is the goal of the Ethereum Foundation also.
Yep, exactly. So yeah, Fusaka, which is a sort of a combination of Osaka and Fulu, which is a star. I think is probably one of our most complicated upgrades so far. And as noted by Olivier, the headliner for this was PeerDAS, which allows us to scale basically blob scaling throughput instead of each node downloading all of the blobs. A full node only needs to download some percentage of the blob. At the moment, I believe it's 1/8 of the data, which enables, theoretically speaking, 8x throughput. So this is basically the start, in my opinion, of the Ethereum scaling.
Yeah, perfect. Yeah. As a eyes of the users, I think that all the users' experience will drastically change in a good way for the Ethereum communities. And so I have one other question, maybe for Arthur and Olivier, is why it was so critical for Linear to be on time with the upgrade?
I can start, Olivier, if you want. So one of our key goals at Linear is that we are building this incredible prover technology that helps scale Ethereum through the Linear mainnet, but we don't want only this technology to benefit Linear, but also Ethereum. And so Kev and the rest of the Ethereum Foundation and Ethereum community are leading the effort to snarkify the L1, so using zero knowledge proof to scale the L1 directly, and it will be involving using existing proof system, and we hope as Linear to participate into that. But one of the requirements, obviously, if you want to prove Ethereum L1, you need to be on time with the fork. And it has been like one of the major concerns for a year of our ZK EVM approach, that it could be like too slow to develop. And I think by being on time with Osaka, we take a step to demonstrate that actually, no, we can deliver.
Yeah, and Olivier, quick question. How did we manage to be on time for this upgrade? Can you explain the story behind this?
Yeah, I mean, yeah, thank you, Simon. I mean, if you take the story of Linear as a whole, it's like basically 3 or 4 years of getting to London, and then a sort of a absolute marathon speedrun, as it were, to get from London to through all the hard forks to the current one, which is Osaka. So we had it took us quite some time to lay the foundations, to write the entire arithmetization of all the opcodes, all the stuff that happens, etc. To build the tooling, to develop the tooling further by having more powerful expressive tools, basically, and rising to a high degree of expressiveness with ZK assembly, etc. We built an incredible foundation that was an immense amount of work. And that led to basically us releasing on mainnet, fully proven earlier this year. In the interim, it's just been a game of catch up. And that meant going through all the EIPs that basically affect the EVM and doing so at a breakneck pace, basically. And so what it involved, I mean, it involved, first of all, a lot of engineering work. I mean, there's a lot of work besides just the arithmetization itself and implementing EIPs. There's all the stuff around deploying hopefully seamlessly on L1 and sort of having forks lead from one to the other. But it also involves just a lot of engineering around and a lot of test vector development, etc., to build confidence in what we are building in sort of an abstract way on our side. So yeah, it's a combination of a lot of work from engineering, semi kind of research stuff, a lot of understanding of EIPs, how they interact, etc., what kind of changes it brings to the system. A lot of the stuff we had in place stayed as it is, but we had to do adjustments to accommodate for like totally new features such as system transactions or changing semantics of opcodes or precompiles, etc. It's a never-ending stream of work. It's also extremely rewarding, but it's just a lot of work, to answer your question.
Just to emphasize that real quick, and apologies to Kev for dwelling on this, but I don't think these guys are tooting their own horns enough. When you talk about speed running those hard forks, you sped run about 4 hard forks in like what, like 6-9 months? I mean, certainly less than a year. A lot of work.
Yeah. And I mean, there's other stuff that happens, which, I mean, for instance, if you talk about the hard forks, there's Paris, which came right after London. Paris had changes to the consensus mechanism, etc. This didn't directly affect us, but it affected other parts of the team. So there's even the one hard fork that is sort of minor from our perspective ended up being a lot of work for other people.
Since when, Olivier, you had this objective in mind to be ready for the upgrade of Fusaka in real time?
The honest answer, Simon, is it happened very recently. So we were ready for Prague a few months ago, and then came the question of, can we make it for Osaka? And that decision and the work that the time span we had for Osaka itself was very short. So it was not at all a done deal until let's say 1 month ago or something, that we would make it right on time. We knew we would be very close to the deadline. The question was, would we meet it or would we delay? And we made it, which I think everyone here is very happy about. But it was the go no go decision. I can't say it was like 2 months ago or something. It was far more recent.
I have the perfect transition for Kev. Can you explain us why it's important for layer 2 to be in real-time proving with the layer 1?
Oh, sorry, I didn't fully get the question.
Sorry,
My
yeah.
mic is...
Can you explain us why the real-time proving is important for the Ethereum layer 1, but also for all the Ethereum communities and the ecosystem with the layer 2, etc. And to be upgraded on the day 1?
Great. Yeah, so most of it is to do with scaling. Real-time proving is in some ways a different way to scale. Currently, everyone is doing everything, which means that if you want to scale, like everyone has to do more as you scale. Real-time proving brings the sort of asymmetry between 2 actors. So instead of the validators re-executing each time, the validators now verify proofs. And there's this other party, which is called a prover, who now has to do more work. And the prover is going to be less decentralized, but the validator set can become more centralized. So I guess in a few words, real-time proving allows you to increase the gas limit and also reduce the floor. And I think the work being done by L2s to sort of speed run all of this is like super important. It sort of battle tests a lot of the software that we're using.
Yeah, thank you. And a question for Arthur: why it's important to be in time for the upgrade, but also why it's important for the user, the builders, even the institutional, to be in a network who can upgrade each IP of Ethereum on day one.
Yeah. So like to like meet like the real-time proving vision that Cave highlighted, you have like quite like technical requirements that like are within reach today, even like still a bit challenging, but like having very fast proof so that you can verify to the next block, having the right level of security of the proof system, a few things like that. But one of the prerequisites, as I mentioned, is also just when we like deliver this vision of real-time proving for Ethereum, when you have like the next fork, you want all the provers to run day one on the new fork. So you need, with our ZK EVM approach, we think that it's it's an approach that will allow some more efficiency, but like the downside is a lot of development work. And so, as I mentioned, one of the concerns was speed of development, and this shows that we can meet this. Now, to answer the second part of your question about what it means for the user specifically, on the L2, it means that you will have the feature of Ethereum day one on the chain. Whether you are a developer that want to integrate like a nice UX with passkeys that we mentioned, whether you are a user and so on, we will always have the feature. You will not be limited by delays of implementing the EVM specification.
It's a perfect transition for you, Olivier. What does that mean for the future of Lina? How we will catch up in the future of the upgrade? What will be the key advancement we can make on your side to be on real time for the future all the time?
So some of that is, so we know that we can keep pace basically with the rhythm of hard forks. This sort of period of over the last year kind of shows that it is doable, and we've done it. The other facet to this is that we are slowly sort of transitioning internally and how we do the arithmetization from a very low-level approach to a more structured approach through the ZK assembly language. What that concretely means, besides, well, it means several things. It means that it gives us a faster development cycle. It gives us greater ease at upgrading existing or slightly modifying or even greatly modifying existing circuits. It also gives us security, because this language, by its regularity, just by the sheer fact that it is a standard programming language, is much more amenable to like formal verification, for instance, tools. So the upgrade path is basically simplified a great amount by us transitioning silently in the background from the sort of very hands-on approach that we had for years to this more structured, more programming-like approach. And yeah, one of the benefits is that once we have ZK assemblified a circuit, well, implementing a change to, let's say, the semantics of self-destruct, or implementing a change to the pricing of ModX it becomes a much easier task than it previously was. So it's yes, it basically the tooling sort of the progress on tooling sort of helps us keep pace.
Thank you, Olivier. Last question. Looking ahead, what are the key milestones for Ethereum Foundation, but also for Linear? Maybe, Kev, you can start with this, with the key milestone and the features we will have in the future.
Oh, yeah, definitely. I think the key milestone, especially for next year, is what we're calling optional proofs. And this allows some parts of the validator set to now verify proofs instead of re-executing. So it's like a soft rollout of ZKVMs. And this allows us to integrate all these different ZKVMs that are being used on the L2 into the L1 without being load bearing. So this is the first step you can think of in terms of Ethereum fully embracing ZKVM technology.
Thank you. Arthur, maybe?
Yeah, sure. So to start like more like discussing the prover and monetization. So we are now at Osaka. It's not yet full EVM compatibility because we still use a different state Merkle tree function that we need to change. So we need to switch MIMC to Ketchak and just use the same data structure of Ethereum. This is like a work that is being done by Olivier and team. One of the key other requirements for real-time proving is to be able to prove blocks under 7 to 10 seconds. So we have like a big upgrade called switching to small fields for arithmetization that is going live in January, and we expect like almost 2 orders of magnitude of speed improvement that will help us reach this target. Those are like the two main aspects to reach the real-time proving. There are other requirements like security that I mentioned. We are already at 128 bytes of provable security. We have not even started doing hardware acceleration. So all the system and proof that we run already use like commodity hardware, let's say, that is quite cheap and will deliver fast proof with not too much expense, which is also very important for the user of the linear chain, because it means that by making the prover more efficient, we can like both reduce the gas prices, get more throughput, but also, as you know, like we use all the gas fees surplus to burn both ETH and linear token, which will improve like the economics of both tokens. But maybe Olivier, you want to speak more a bit about like the arithmetization roadmap.
Thanks, Arthur. I mean, you hit most of the big things. There's transitioning to type 1, so you talked about the state representation, etc. There's the small fields performance boost, and then obviously going to Glamsterdam, hard fork, etc. But I think you covered most of it.
Thank you, Olivier. Thank you, Arthur. Last one, maybe around the security. Yeah, Kev.
Yeah, I just wanted to make a quick point. The Ethereum's cryptography research team, George and Arancha, are working on a blog post, and part of the end goal for ZKVMs is to actually have 128 bits provable security. So it's actually great that you guys are already there. Yeah, I think that's amazing.
One question for you, Kev, like what do you see as the most important or maybe most challenging of the constraint or requirements for real-time proving system going forward? Is it security? Is it something else?
Right. So I think we just can't compromise on security. Like we just need 128 bits provable security. And this does have some downstream constraints, like how big can the proof sizes, like how big the proof sizes actually get. The proof sizes being large is kind of a big issue for us because they do need to be transmitted on the P2P network. And that currently is not extremely efficient. We have a P2P networking team that's working on it, but you can imagine like 300 kilobytes proofs are going to be a bit of a pain for our networking. So I'd say the proof size is one thing that we really want to work on getting down. I believe you guys might be looking into where as a way to get it extremely small, but I don't know what your progress is there.
Do you want to take the question, Olivier?
So are you talking about uncompressed proofs, or are you talking about blobs, or I'm just thinking of the proof sizes that that I have in mind, which are closer to 128 kilobits at most.
Yeah, so these are uncompressed proofs. If you mean by uncompressed, like not having a final like Groff16 wrapper, currently we're thinking of not having those. This decision might change, but if we do have it, then proof size becomes not an issue. So yeah, uncompressed.
Yeah, so our Vortex proof is like 8 megabytes at the moment, but we have like a Planck wrapper that makes it only 4 kilobytes to reach like the target of being under. For us, it will even be 200 kilobytes. We will use WHIR, as you mentioned, to that will get us to this stage.
Thank you, Arthur. Thank you. Olivier, quick question for you. I hear the first transaction is coming also on linear, which means we are getting closer to the stage 1 on L2 bits.
That's right. And the way it happened is kind of it's a sort of a minor miracle the way it happened, because one of the maybe surprising from an outsider's perspective difficulties we had with false transactions was connected to a very specific precompile, which is modexp. And it just so happened that in the Osaka hard fork, the semantics of this precompile converged with the one with the ones we already had internally. Obviously, we're proving modexp as anybody else would, but we had internal limitations on the sort of acceptable size of modexp we could prove in our circuits. In any case, somehow we arrived at very similar sort of conclusions by totally independent means. And as a consequence, this blocker we had sort of lifted itself. And it's very nice because I guess the situation is now that there are no transactions that on Linear where Linear is sort of unable to sort of justify, for instance, that this transaction cannot be included in a block. So it removes an alley for like censorship that outside users might perceive or something like this. It's an anti-censorship mechanism which was somehow enabled by the Osaka hard fork, and at least on Linear. And so it's going like.
It's a wonderful because we will get the stage 1 in Q1 2026, I think, Arthur. Yeah. And we have the 128 bits of security, which is we can be proud of it.
So all in all, this means that by Q2, like probably end of Q2, we will meet like all the requirements that have been defined by the Ethereum Foundation for like real-time proving. That's our goal.
Okay, thank you. Maybe we can give a round table with the last word for everyone, for the Linear communities, for the Ethereum Foundation communities. Kev, maybe you can start. You are our guest. our wonderful guest. So I give you the mic.
Yeah, thanks for having me on. Yeah, definitely. I think all of this is exciting. It's definitely great to see people working on this. These are extremely hard problems to solve. So I think it's very good to like celebrate them. And I'm very excited for all of this to come into the Ethereum ecosystem.
Thank you, Kevin. Arthur, maybe, and then we finish with Olivier.
Yeah, so I mean, I mostly want to celebrate Olivier, the arithmetization team, like the Prover team that has been like led the effort to like achieve the milestone today of reaching Osaka. That is really great. Like, job is not done yet. We are still a lot of work to do. We believe the direct arithmetization of the EVM can yield a very interesting result. Have the opportunity and like the benefit of bringing the diversity also to the proving pipeline. So that's a bit like when like back in the days macOS was not like a very like broad, like you would not get malware because it was different. It's not like, yeah, we are not talking about malware, but we are talking about like a bug that would happen in RISC-V. And so having this diversity as well on the prover layer, we believe could increase the overall resiliency of Ethereum with the same approach that we see with execution and consensus layer. So we are very excited to be driving in this direction and to participate.
Olivier, maybe a quick one.
Yes, I'm just very happy to be working with the people in Linnea, the people that I work with, whether that's my team or the engineering team or the prover team, who've done outstanding work. And I'm very much looking forward to 2026.
Awesome. Well, hey, thank you so much to all of you, to Kev from the Ethereum Foundation for signing on and talking Fusaka and Ethereum and Linea with us, and also obviously for Olivier and Arthur for your great work that really makes Linea possible, and Le Chiffre for keeping the ball rolling on the technical marketing side. And also thanks for setting up this stream. And behind the scenes, thank you to producer Joe. And thank you to you for tuning in to the SomEThing podcast. Happy Fusaka Day, everybody. Happy Fusaka week. We've got holidays coming up, but still much more coming from Linea soon. So we will see you next time. Thanks all. Bye.
Bye, sure.